So how are you?
It's nice to meet you. My
Nice to meet
pleasure.
you. Yeah.
I,
So
I'm today. I'm a bit how to say. Maybe my mind is a bit cloudy because I have COVID and I'm not so sharp as I
how to
would like to
say?
be. But I think everything will be fine.
Okay. So are you feeling well, or do you want us to continue, or what?
Oh yeah, of course. I want to continue. I feel very
Okay.
good, but I'm not. My mind is not so sharp as it should be. But that's
Okay.
that's
Okay.
that's the only thing.
Okay. Yeah, sir. Should we start, Kunal sir? Yes, sir. Yeah. Asta, can you give a quick introduction to our guest speaker?
Yeah, so am I audible? Hello?
Yes, Asta, you are audible.
Yeah, yeah. Yeah. Good evening to one and all present with us today. Visualization, in its essence, is progression of imagination which drives all the scientific and natural thought processes around us. So, in a world propelled by quest for solutions pertaining to health as well as the disease, the field of image processing and analysis is both crucial and decisive. In this slide today, we have Professor Slobodan Wilczynski, head of the chair and Department of Basic Biomedical Sciences, Faculty of Pharmaceutical Sciences, Medical University of Silesia in Katowice, Poland, to enlighten us on the topic application of image analysis and processing methods to drug evaluation. SIR's research interests are focused on modern imaging methods used in medicine and pharmacy, indulging in particular hyperspectral imaging, dynamic thermovision analysis, high resolution ultrasound, as well as other techniques such as EPR, NMR, and hemispheric directional reflectance. Sir is also the author of over 130 scientific works, patents, and industrial designs, and is an expert of the Polish National Center for Research and Development. And he is also a member of the investment committee in the Bridge Alpha NCBR program and an expert of the Polish Ministry of Funds and Regional Policy, Polish Medical Research Agency. Additionally, Sir is also the editor in chief of Aesthetica, a leading journal in the field of aesthetic medicine and dermatology. I now invite Sir to begin with the seminar.
Thank you very much. I'm very pleased to have occasion to make some talk. A special thanks to Professor Kunal Pal. Thank you very much for giving me this opportunity. And of course, a special thanks to Professor Bala Sharkantahi for this special occasion for me. So thank you very much. My presentation is concerned the image analysis, which I'm about working with from a few years, and I would like to show you some modern image analysis, which can be used for drug analysis, not only in pharmacology, but also in aesthetic medicine and so on and so on. So let me start from the beginning. Okay, my main merit of the presentation is focused on thermal imaging, high frequency ultrasonography, clinical photography, 3D scanner, hyperspectral imaging, microthermography, and hemispherical directional reflectance. I'm not sure if I'm able to show you all the of the methods, but I hope it will be available in this short time of my lecture. So the third thing is connected with thermal imaging and the warming and warming preparation, which are traditionally used in muscle, joint, and nerve pain. and warming substances due to their vasodilator action cause local congestion. Therefore, they can be used as permission promoters, and warming formulation and medicines are sometimes used to speed recovery from injuries, and cooling preparation are used in muscle joint or spine pain, braces, edema, and well as reduce the effect of heavy legs. The substances most often used as warming agents are capsaicin, camphor, methyl niconidate. In contrast, methyl alcohol and isopropyl alcohol are used in cooling agents. And the analysis of thermal images only in some areas is consistent with the analysis of image in visible light. It is difficult to work and interpret results for virtually every operation in image analysis and processing. There are problems with separation, segmentation of objects with very little temperature differences. And there are problems with sharpening of the edges due to the natural blur, convection of temperature and ambient temperature in the case of objects warmer than the room. In modern thermal camera, which have very high resolution, the problem is not so big, but it still is important. In case of test conducted on the patient, there is a problem with the individual impact on the results. For example, if they eat some warm meals consumed before the test, obtaining thermal comfort in the room, undisclosed illness, contact of the measured area of the body with extraneous object causing a local increase of temperature, and so on, so on. Also, the implementation itself of cause lots of problems with automatic data analysis is a big problem. In this case, the preparation of warmth and cool after application of a topical formulation is not very well correlated with the skin temperature. It's very interesting because we naturally think that when we apply a cooling substance, the skin will be cooler, but we concluded that it's not so. It's not going like that. So assessment of the effectiveness of preparation having a cooling or warming effect with the use of subject analysis of thermal sensation perception is not possible. Warming and cooling substances can cause a cooling or warming effect on skin without changing of its temperature. This is due to the fact that the perception of thermal sensation is based on the activity of receptors that correspond to external stimuli, and the simulation can cause a give effect. Example, skin warming does not have the physical temperature change, but it can be chemically. So can be chemical. So in addition, I can say a major lowering the skin temperature in the weight of the formulation is very important in practical application. So to sum up this this part, the skin temperature is not correlated with the sensation of the skin. So sometimes we feel warming or cooling, but the temperature of skin is not changing, and it's quite surprising. The second thing is connected with thermal imaging and laser treatment optimization. It is connected with the aesthetic laser procedures. Because efficacy and side effects of medical aesthetic laser procedures are highly operator dependent, both when using ablative and non-ablative lasers. A key factor in laser treatment is appropriate selection of laser parameters and treatment technique. One of the most common cause of side effect is stacking of laser pulses. Beside the pulses stack, patients report growth discomfort, burning sensation, and pain. However, some procedures involve laser pulses overlapping with results from deeper laser penetration in dermis, especially lower devices, low power devices. So when laser pulses are overlapped or stacked, and you can see it on the picture like here. So you can see that laser pulses are stacked each other, and the energy of laser just here is multiplied. So we can suspect that there will be a massive heat effect just right here. And it can cause ablation of dehydration underlying skin, and a heat sink can occur, resulting in focally increased heat penetration. And this may happen in case of too rapid pulse frequency or too slow operator's hand speed. In case of CO2 lasers, pulses are repeated, overlapped, and the dermal collagen will be dehydrated and coagulated. And image overlapping is implemented based on, in this case, we use a new method. The method is based on isomorphism of graphs. And it's quite interesting because the graphs are structures which are result of graphical interpretation of skin ridges. And we can create graphs based on skin ridges, and the top of the skin ridges create graphs. The mathematical description of graph includes a determination of the ratio of the distance between the verticals of the graphs and the angles formed by these verticals. This allows for the matching the successive image containing graphs, even when the quality of recorded image, for example, in case of thermal imaging, is not perfect. Such a situation occurs during a laser treatments performed with the proposed technique, where the laser head and with an attached camera moving across the skin can observe the same skin at different angles and different lighting conditions. So the these graphs which are used in this case are really interesting technique. And the graph isomorphism, when we used to use in this case, take place when the structure of the compound graphs is identical and the characteristic attributes of the graphs are, I mean, the edges and the verticals of graphs are the same. However, in many cases of image analysis processing, including this one, there is a need to find isomorphism with respect to subgraph, so-called subgraph isomorphism. And this issue is important to image processing since the information about the graph is most often incomplete, redundant, I mean numerous references are not measured and not detected characteristic element, points, edges, which form of graph. And inaccurate correspondence of graphs allow for variation in both the values of graph attributes and their structure. In addition, in complicates determination of measures of similarity between graphs and subgraphs. So we proposed a new method and system of automated pulses, and you can see here this is the image of the skin, and the blue points makes the skin graphs, and above you can see the mathematical interpretation of the skin graphs which are created by the skin ridges. And what is important, the most important is the angle between the ridges, and based on these angles we can very precisely create algorithm which enable us of produce a system of automatic emission of laser pulses. And the proposed method do not only allows to precise automatic triggering of subsequent laser doses, so that the pulses are perfectly arranged, but also reduces the treatment time, which the proposed algorithm parameters enables irradiation in the skin with a frequency about 2 Hz, which is absolutely not possible in case of manual triggering of the laser. And moreover, the use of more efficient computational units, I mean more efficient computers, can increase the speed of triggering even a few times more. Another modification exceeding the scope of this this presentation is an algorithm modification which allows for a control precise, for example, 30% of overlapping of successive pulses, which could result in a potentially positive clinical effects in certain indication, but as I said, it's beyond this presentation. The next, my next issue is connected with also aesthetic procedure effectiveness and genoid lipodystrophy. And genoid lipodystrophy is one of the worst tolerated aesthetic defects. It affects from 80 to 90% of women after puberty, and among factors predisposing to cellulite are gender, race, body weight, age, and so on and so on. And in case of cellulite, we have imbalance in microcirculation, and due to this imbalance, we can maybe I will say another word. In microcirculation disorders is manifested by abnormal temperature of the skin covered in cellulite, can be basis of determine and different scales. Analysis of skin temperature can be implemented using for example, thermographic method, but this thermographic method must be supported by any image analysis and prosthetic methods. And in this case, we used to use a very interesting method. I'm not sure if you ever heard it, but it's really interesting. I mean, gray level concurrence matrix method, and it can be used in any case, also in thermograms, and we use it first time for analysis of thermograms. And the gray level concurrence matrix was used to determine the homogeneity of the distribution of the temperature fields on the patients before and after treatment, and the contrast calculated on the basis of GLCM was adapted as a measure of homogeneity. The idea of GLC method is that to calculate the number of neighborhoods of each pixels in the ROI indicated by operating in the entire image. Here is the you can see the artificial interpretation of the image, and what I mean, which of this A or B image is more homogeneous. And we can see that in this, both in these cases, we have 30% of white pixels and 30% of black pixels. But which one, A or B, is more homogenic? And the answer for this question gives us the GLCM method, and exactly the same, we can answer the question if the temperature of the skin is homogeneous or inhomogeneous, and if the temperature is more homogeneous, the skin is the cellulite is not so severe. So we can analyze not only the cellulite, I mean lipoid dystrophy, but we can also to find out if the treatment method is effective. So it's quite interesting method. The next thing is connected with very huge problem. I mean, drug counterfeiting. Drug counterfeiting is the one of the most biggest problem of the modern world, and because the risk of injury of inpatient when taking counterfeit drug is very high. According to World Health Organization, the extent of drug counterfeiting cannot be clearly determined, but is roughly estimated at about 10%. I mean, about 10% drugs in the world are counterfeited. So, of course, the phenomenon of the drug counterfeiting is much more common in developing countries, like, for example, in Africa, but also in highly developed countries like, for example, United States, Japan. It's also a very big problem, and currently numerous medicine and dietary supplements are very skillfully falsified. So the visual inspection, disintegration test, or color and shape analysis of tablet do not allow for 100% identification on counterfeiting drugs. So in order to assess whether a drug has been falsified or drug itself or its packaging can be evaluated, many analytical techniques for determination the authenticity of medical generally are focused on determination of the content on active substance, I mean active pharmaceutical ingredient. And for this purpose, different techniques can be used. For example, HPLC, mass spectrometry, Raman spectrometry, Fourier transform, infrared spectroscopy, and so on and so on. But these techniques are quite expensive, and you need to have very sophisticated machines. So on the image right here, you can see original and falsified Viagra, and is it possible to determine which one is original and which one is counterfeit using a thermal camera? It's possible, because we can record the thermographs of for these two drugs, and we can compare them. And how we try to compare the drug. So first of all, objects precise the dynamics of this process in mind according to the special exposition. And the use of dynamic thermal analysis allows for the rapid withdrawal of the counterfeit drug from the market. Why? Because using, for example, HPLC or any other different methods, we can analyze only one tablet, I mean one by one. By using this method, you can check at the same time 100, 1000 on how many how many tablets as you want. So this method is have some advantages. I mean, it's quite simple, or maybe very simple. It's quite cheap because a thermal camera is very cheap. You can buy a quite good thermal camera by $1,000. So it's many times cheaper than HPLC or any other laboratory sophisticated equipment. So the use of dynamic thermal analysis is effective because it can we are unable to compare even very similar drugs. It's cheap, as I said, because thermal camera is very cheap, and the method is very fast. It takes about 40-60 seconds, depends on the drug, and the examine differences of time constants. I mean time constants. I mean the in this case the time, there's the constant which says us how fast or how fast the drug is heating or cooling, and it's very specific for the not only the substance which the drug is made, but also is very is crucial for the methods of the drug producing. So the method is very precise, so it's effective, cheap, and fast. So we think that's quite interesting method for falsified drugs determination. Another method which I'd like to present is very interesting. I'm very fan of this method. It's directional reflectance analysis, and the method of directional reflectance analysis is originally used in a space agency or space products because it's used for measure of the effectiveness of the solar panels on satellites. But we use this method to compare counterfeit and original drugs. And we used a commercially available directional hemispherical reflectometer from Surface Optics Corporation, San Diego, USA, and we equipped the reflectometer with the head with two, which enables to measure two different angles of incidence. I mean 20 and 60, an angle of 20 and 60 degrees for 6 different wavelength bands from 0.9 micrometers up to 12 micrometers. The integrating sphere captures the reflected light from the target material, I mean in this case of tablet surface, integrating reflection in all directions, and wavelength filtered detectors measure the total light reflected in each wavelength band and converts it to analog an electrical signal which we can measure. So you can see this 1, 2, 3, 4, 5, 6 different bands, and in which band we can compare the absorption of light, I mean maybe radiation, it'd be better say, and we can compare the absorption, transmission, or reflection of radiation, and then we can say if the drug is original or it's faked. What is very interesting, the fact, so it's very that the reflection and transmission or absorption of radiation by the surface of the drug is connected not only with its composition, but it's very highly connected with its surface analysis. Even small differences in surface of the tablet make a great divergence in directional reflectance. So the method is very, very sensitive, and the findings of the directional reflectance for the original Viagra and counterfeit tablets from the first batch tested, we find out that using 6 spectral bands give us almost 100% of sensitivity. So to sum up the directional reflectance analysis and enables to differentiate between the original and counterfeit tablets. In this case, we also can see the Viagra. Why Viagra? Because it's one of the most counterfeited drugs. And identification of counterfeit drugs using this method, directional reflectance analysis, is based not only on difference in chemical composition, but on its physical parameters, on the structures. It's very important because up to 2% of counterfeit drugs have the same chemical structure, chemical composition as the original one. So you can also find out and you can identify even the a chemical copy of the drug. So this enables to distinguish between original and fake drugs with identical chemical composition, but different production parameters. For example, various compression force during tabletting, various degree of ingredient fineness or thickness or coating, and so on and so on. So the proposed directional reflectance analysis is a fast measurement under 5 seconds, effective, cheap, maybe not so cheap as thermal imaging, because thermal imaging the cost of thermal camera is much cheaper. The thermal camera costs about $1,000 and the reflectometer costs $50,000, so it's much more expensive, but still much more cheaper than, for example, HPLC or mass spectrometry or so on and so on. So the proposed directional reflectance analysis is also very fast, because the measurement, the simple measurement is under 5 seconds. So it's effective, cheap, very sensitive, and it has very high specificity. So it does not require expensive equipment or specialized laboratory staff, because why do not require specialized laboratory staff? Because the measurement is very easy. So you just put the head of reflectometer to surface of the tablet, just put the trigger, and in 5 seconds you have the results. So thus, in the era of rampant practice of drug counterfeiting, it will enable screening of the large numbers of samples and the withdrawal of the fake drug from the market. And moreover, it should be helpful in eliminating from the market players responsible for placing fake drugs, and I hope it can be used in this method. And the next issue is also connected with counterfeit drugs, but quite a different method. H1 nuclear magnetic resonance reflectometry, and it's very nice and very unique technique, probing mechanisms and characteristics, time constants, and dynamic process in the condensed method from simple liquids via macromolecular systems to solid, based on atomic levels. And in contrast to NMR spectroscopy, which is focused on molecular structure, NMR reflectometry probes molecular dynamics. So this summarizes the concept of the work. As it turns out, the structure-oriented methods do not prove the sufficient for discriminating between original and counterfeit products with PDA 5 inhibitors. The next try is to attempt to reveal characteristic dynamics features of these materials. I mean, this method will also be very useful in case of drugs which are the copies of the original drugs. So the standard NMR relaxation experiment are performed under single frequency, for example, 400 microhertz and so on. In here, the experiments are carried out in the frequencies in very high range, encompassing 4 orders of magnitude from about 5 kilohertz to, let's say, 14 megahertz. And this is possible by applying fast field cycling technique, which has introduced by new dimension in relaxation studies, namely the possibility of the varying of frequency. And we found out that the original Viagra and counterfeit Viagra have different time constants, and based on these time constants, we can very precise divergent between these two drugs. I mean, this also was Viagra. I mean, counterfeit Viagra and original one. This method has no so much advantages as previous one. So when we compare it, for example, to previous method, I mean for directional reflectance, this method is very expensive because the reflectometer is very expensive. It's time consuming because one analysis takes more than few hours. You can perform only one tablet and during one measurement, so it's also very time consuming, but it have one big advantage. So you can find even the smallest differences in molecular dynamics of API or any other structure of the drug, and you can divergent it very precisely. So the method is very expensive, very time consuming, but it's very nice in case of copies of the falsified drugs. The next thing. My next slide is connected with atomic force microscopy. It's also a very interesting method because we can find some differences in height, adhesion, dissipation, and many different parameters of atomic force microscopy in counterfeit and also in original drugs. The same as in reflectance, I mean hemispherical reflectance, you can also compare the drug with the same chemical composition, because the parameters of atomic force microscopy are not directly connected with the chemical composition, but also with the production method. I mean, for example, tableting strength. So the method is very precise. It requires also very sophisticated method as atomic force microscopy is, but I think it's worth of your attention to counterfeit drug identification. And the next method I would like to present you is hyperspectral imaging, and I must say that I'm a big fan of this method. It's one of the most interesting methods which I'm focused right now, because what is hyperspectral imaging? Um, Hyperspectral imaging techniques enables to determine both morphological and molecular properties of the analyzed objects, which is quite unique. And hyperspectral camera performs image acquisition by recording the radiation of different energy intensity and the wavelengths in the specific range of spatial coordinates and wavelength. So the values of spatial coordinates are represents the morphological parameters of the image or object, but the wavelength represents molecular parameters. So in the same time we can find out about the morphological and molecular properties of the object, and only hyperspectral imaging gives us such as opportunity. And sorry, in this case we tried to find out, is it possible to use hyperspectral camera to identify very similar drugs, I mean the counterfeit one and original. And the conclusion for our results are as follow. The hyperspectral technique supported by mathematical methods and methods of image analysis are enabled to distinguish with 100 probability between the original and counterfeit medicine. What is important, this is not a destructive method, and when we compare it, for example, in mass spectrometry, these methods are destructive, and in this case the method is undestructive, not destructive, and allows the performance of a screening test of dozen of samples can be examined at the same time. So the same in like in thermal imaging. In case of directional spectrometry, directional reflectance, we can check the tablet one by one, and in this case we can examine at the same time dozens of tablets, and these enable reliable, time-saving, non-destructive analysis for a quick withdrawal of counterfeit drugs from the market. And in this case we used a method of analysis which is called PCA, and this method allows for effective visualization of ingredient distribution. You can see it right here. So the darker and darker spots correspond with the distribution of some ingredients, and we know which ingredients because we have full spectra from each pixel. And we used to use the same method here, like in for cellulite, so I mean GLCM. So the use of PCI allows for distribution for both original and counterfeit tablets, and the GLCM analyzes and enables to quantify the homogeneity of distribution of tablet ingredients with additional differentiating factor. And so we can conclude that use of hyperspectral imaging in the range of 1000 to 2050 nanometers can be lower wavelength, because it enables to analyze not only the outer coating but also content in a range of several to 100, maybe 200 micrometers, because the higher wavelength, the better penetrates to the material, and in this case in the tablet. And the hyperspectral imaging can be also used for to analyze skin properties, and here you used to spectral imaging to analyze in a quantitative way, which is very interesting, the melanin and hemoglobin in skin of hand. And is very interesting. We can find out not only if the melanin is distributed homogeneously or not homogeneously, but using specific mathematical modeling methods, we can also find out how deep is melanin. And it's very important not only in the case of aesthetic medicine, but also for dermatology. I mean, for example, for melanoma identification. And this method, I mean hyperspectral imaging, is very well, promising, or I mean a very promising method to identification of melanoma. And I think this will be one of the most interesting method which can prevent us from melanoma. Hyperspectral imaging can be also used for historical cellulosic objects. This is our new project, which is not connected very strictly with the drugs, but it's very interesting, and I decided to show you something more. And in case of historical objects, one of the most danger is the colonization of the object with the microorganisms. So many tries are attempt to sterilize these products, but how to sterilize this product? Let's say historical cellulose objects. There are not too many methods which are not destructive, and one of the most interesting method is laser method. But if the laser will destroy or not destroy the object, and we cannot just try, because this is a historical object and we can not destroy them during the probes. So we have to answer the question: can we use the laser to sterilize the object without any scars or any other methods? So using hyperspectral imaging gives us such a very good opportunity to answer the question how the laser radiation will be or maybe different. The hyperspectral imaging gives us an answer if the laser radiation will be destructive or non-destructive for the historical cellulosic objects. and that's why it's very promising method for analyzing the interaction of laser with historical and any other objects. And one of the last method I would like to present to you is microtomography. And microtomography is a very interesting method because it enables to use the 3D structure of tablets. In this case, we would like to find out if the tablet splitting is good for patients. And I mean, if we split the tablet, even if the mass of tablets is the same, if the API content is the same in the two different halves of the tablet. I mean, these are not halves because are not the same. I mean, parts will be better. Will be better. So when you split the tablet, even if the mass is the same, the concentration of active pharmaceutical ingredient is also not the same. The conclusion for our studies as follow. Not only some tablets can be splitted, which tablets cannot be splitted. For example, like in this case, the tablet which contains specific internal structure. This tablet contains pellets. So when you split it, the pellets can be not homogeneously distributed in different parts. I mean, not only the amount of pellets, but also the volume of pellets is very important, because the volume of pellets, the surface of pellets, is compared with kinetics parameters of the tablet. So using microtomography, you can analyze very precisely the internal structure of the tablet, and based on these scans, you can compare like in this case, for example, halves of the tablets, and answer the question: is it possible, and is it good for patient, for example, tablet splitting? About the hemispherical reflectance, I just say a few words, but I would like to focus on a very interesting method and a very interesting problem, which is infrared skin filters, because many cosmetic states that their products can protect against infrared radiation. And if it's possible, we perform some tests, and what we find out that on the market, I mean worldwide market, there is no even one producer, there is no even one product which can protect against infrared radiation. So directional reflectance can be used not only for let's say as I said counterfeit drugs identification, but it can be used for very different from the different analyses. And in this case, we use directional reflectance to analyze if the infrared skin filters can be effective. As I said, they are absolutely not effective. One of the last slide is focused on non-contact measurement of blood pulsation rate. It's quite interesting because we can measure the blood pulsation. I mean heart beating, heart rate measurement using very simple camera. I mean even using camera in the laptop, I mean internet camera, we can precisely measure the heartbeat, and we try to find out if it's possible and what is such a measurement precise, and we are trying to find out if it's possible to detect arrhythmia or any other heart problems using just a simple camera. And we are using, we are trying to find out, and that's one of the most interesting projects which I'm working on just now. And on the last thing, I would like to say something about the use of automatic classifiers, and these classifiers can be used, for example, for analysis of gum temperature. It's very big problem to measure temperature because so many factors influence on this measurement, and using automatic classifiers we can I mean decision trees, naive Bayes, discrimination analysis, SVM machine, we can find out if the method of the gum temperature analysis is correct. So thank you very much for your attention. It was a short presentation of the methods we are using in our department. I hereby welcome you to cooperation. I would like to one more time to thank you, Professor Bala and Professor Kuhn, for the invitation. It was very nice to have a talk. Thank you very much.
Yeah, thank you, Professor Slavomir. Thank you so much. Even you have given a very good presentation on all the imaging techniques. I would like to invite for questions now. Students, if you have any of you have any questions, you can raise now. This is the time for questions. Any questions?
Yes, sir. Can I ask?
Yeah. Please go on, Mr. Prakash.
Yeah, sir. For the directional reflectance process, you said that it can identify very quickly in 60 seconds or 1 minute, something like that. So my question is, what if they counterfeit only the surface or capsule of the drug? I mean, it's not checking the ingredients, right? Only the surface area.
That's a very interesting question. The depth of how depth the wavelength is it's maybe from the different side. It's always it's always possible to differentiate between original and counterfeit drugs, because there are no way if the surface of the analysis of counterfeit and original drug is the same. As you say, it's the depth of penetration of radials of light depends on the wavelength. So if the wavelength is higher, the penetration is deeper. So in case of using reflectometers from, let's say, 1000 to 250 micrometers, it's possible to penetrate even 200 or 400 micrometers to the drug, and the difference of chemical composition and the difference of structure of the drug always give us the answer if it's the drug original or faked.
Okay, thank you, sir.
Thank you.
Yeah, thank you. So any more questions from students? Professor,
I would like to ask a question.
Yeah, please go on, please go on.
Firstly, I would like to wish you a speedy recovery from this coronavirus disease. And I would like to ask you, of all the techniques that you have mentioned, which method is used to obtain images of the highest resolution?
You mean the resolution of the image?
Yes, sir.
In always the highest resolution of the image we can obtain for visual wavelength. But in the case of visual wavelength, I mean from 360 to 770, 80 nanometers, we have a lot of cameras with very high resolution. But in this case, we have only the spectral information about the image. In case of hyperspectral imaging, the resolution of the image is much lower. I mean, in the camera I used to use in my analysis, the resolution of the spatial image was 512 and 412 pixels, and the resolution of spectral resolution was about 3 nanometers. So the spatial resolution in case of our analysis is not so important. The more important is the different parameters. I mean, in case of hyperspectral imaging, the wavelength resolution, spectral resolution, and also using a very sophisticated method of imaging is much easier, and using a low resolution camera is much more difficult. So we are trying to find out, is it possible to detect the counterfeit drugs using low resolution camera, and if it's possible for low resolution, it always will be much easier for high resolution camera. So we picking up the low resolution camera, and if it's possible, it also will be for high resolution. Thank you.
Thank you, sir.
Yeah, thank you. So any more questions? Yeah, fine. Thank you so much, Professor. So Asta, I would like to ask you to give a word of thanks for our honorable speaker.
It was my pleasure. Thank you very much, Professor Bala. Thank you, Professor Kunalpal, and I hope see you. And I hope we can see each other, not only via internet, but personally. Thank you very much.
Thank you so much.
Bye.
No, wait for a second. Yeah. Asta, we cannot hear you. Maybe you are being muted, I think.
Am I audible now?
Yeah, now you are audible. Yes.
Department in Medical Engineering, and I'd like to extend thanks to Professor Slavomir Wilczynski for taking out time from his tight schedule to deliver us with this highly informative seminar. We are also immensely grateful to you, sir, for providing us with the sharp insights on applications of image processing, which would add to whatever little knowledge we are gaining. and in process, and whatever we plan ahead in this field of interest. I would also like to thank HOD sir and all of our faculties for organizing this seminar for us. And finally, to all my students for being receptive and patient enough to seek and soak all the knowledge so shared. Thank you.
Yeah, thank you, Asta, and thank you, Professor. So we can live. I wish you a speedy recovery. So it is unfortunate to learn that you have been affected with the corona. So I wish you a speedy recovery. Thank you.
Thank you very much for your time.